Hey, welcome back to Math with Patrick and Quill. Today is October 17th, and we're solving problem 290 from the Daily Epsilon calendar. And x should be 17 because the answers usually match today's date. So this x right here, this diagonal of the, I'm assuming, rectangle, is, or should be, x. And yes, it is a rectangle because we got like 90 degrees here and here. And then, all of these are rectangles here. And I guess we could just do like a little bit of Pythagorean theoreming on this just to see what we could do with all of these different numbers. I'm like noticing that they're essentially all like hypotenuses of right triangles. So we can see what we can do with that. And let's assign some variables. How about we'll put this as an A, B, C, D. And I'll start with that x. So let's see, Pythagorean theorem just says that a squared plus d squared is going to be x squared. And then kind of going clockwise, a squared plus b squared should be 25. B squared plus c squared is going to be, well, it's this squared. Hold on, I think actually I did the 25 wrong. That's supposed to be 25 squared. There we go. And so if I do the square root of 436 squared, that's just going to get me 436. So I guess I'll write it like that. And then finally, we have c squared plus d squared equals 10 squared, or 100. So I guess over here with this 25 squared, I could just call it 625. And then ultimately, I want to know stuff about a and d, so I can then say some stuff about x. So maybe there's a way for me to collect all this up, use some numbers from here, and maybe eliminate b and c. So I'm just left with a and d. I think I found a way. So let's set up another equation. And I'm going to kind of place some of these on the left side of the equation and some of these on the right. And again, my goal here was to get rid of b and c. So let's just place the first one here. A squared plus b squared is equal to 625. And I'm going to place the bottom one actually here, plus c squared plus d squared. And that's going to be equal to 100. So I'll put a plus 100 on the other side. And I think I'll actually subtract the middle equation. So I'll go minus b squared minus c squared, and then minus 436 on this side. And the point is that I'm able to get rid of b squared and c squared. This cancels with this cancels with that. And then so now I get a squared plus d squared, which from earlier we know that this is equal to x squared, is just equal to this subtraction over here. So maybe let me do 725 minus 436, do some borrowing again, 289. Cool. So x squared must be equal to 289. And what's kind of neat about this is I don't really need to know what A, B, C, and D are. Just by like substituting out those values with squares on them, I just was able to solve for x directly. And so this says that essentially x is either 17 or negative 17, because if we do like 17 times itself, we're going to get, let's see, 49, carry the 4, 7 times 1 is 7, plus the 4 is 11, placeholder 0, 1 times 17 is just 17. So this just shows that yes, 17 squared is 289. And since we're working in a geometry problem, we can assume that we don't have negative distances here. So the only number that works is 17. And that's today's date. So there is my solution. Maybe we could solve for A, B, C, and D, or maybe not. I'm not actually sure, and I don't really care to check. So anyways, x is 17, and I think we're all done. So thanks for watching, and I'll see you tomorrow. Bye.